Hello everyone, and welcome to another Solve With Me video where we'll be talking about and solving together SAT physics practice exercise. So today we'll be talking about simple harmonic motion. Let's begin with the first question. Determine the period of the oscillation. So we know the period's formula, that is time, total time over number of oscillations, which here it is 50 seconds over 20 oscillation cycles. So he in this case equals to 2.5 seconds. Alright, so it's B. Determine the frequency of the oscillation. We know this formula, that the frequency is 1 over time, which is 1 over 2.5, which is 0.5 hertz. So it's A. Let's go to the next question. A 4 kilogram mass is stretched to a spring and lowered to equilibrium. During this process, the spring stretches 2 meters. Determine the spring constant. So let's draw here a spring and a mass attached to it, an object. This one is the weight, and this one is spring force. And during the equilibrium, we know that these two forces magnitudes are equal to one another. So we will just write their formulas. This one means that K equals to, this is what we need to determine. Okay, we have, so we know here it's 4 kilograms times 10 over 2 meters, which will be equal to 20 newtons per meter. So it's C. Alright, now let's go to the next question. Which of these factors affects the period and frequency of an oscillating spring? So we know that the period of an oscillating spring is 2 pi square root of m upon k. So it's mass attached to the spring, and spring constant. So it's 1 and 3 only. So it's E. Alright, now let's go to the next question. Which of these factors affects the period and frequency of a pendulum? So we know that an oscillating pendulum has the period of 2 pi square root of L over G. So it's length of the string, yes. Displacement of the mass from equilibrium, no. Mass attached to the string, no. So it's just 1 only. A pendulum oscillates with a period of t. If the length of the string is quadrupled, what would be the resulting period? So we know the formula that we just talked about. 2 pi square root L over G. So if this one would be quadrupled, then this one, the period would be double, because here is a square root. So in this case, it will be equal to B. Which of the following is Hooke's law? D. It's pretty obvious. The diagram below shows a mass spring system, blah, 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 blah. 1 and 3 are the maximum displacement, and 2 is the equilibrium position. All right. To which position is the kinetic energy the greatest? During the equilibrium point, so it's 2 only. So it's B our choice. At which position is the acceleration the greatest? So we know that the acceleration is the greatest during 1 and 3 positions. So it's E. Alright. Which graph correctly depicts the total energy during an oscillation? We know that the total energy is always constant. So the perfect graph for this would be E, because we know that a graph of a constant function looks like this. So that was for today. Thanks a lot for watching, and do not forget to subscribe for more videos like this.